activity, the aim is to understand how quantum computers can be useful even if they give us random outputs, and we'll be doing this with a little activity using numbered counters in a bag. So far, we have learned that when we look at or measure a quantum computer to try and get information out, such as the answer to a calculation, the outcome that we observe is random. In other words, quantum computers give us random outputs. So how can they possibly be useful? For example, if we are trying to add two numbers together, we want the computer to tell us the correct answer, not just some random number. But as we'll see, even if our outputs are random, sometimes we can still get useful information in a reliable way. In front of you are some bags with some counters inside. Each of these counters is numbered with some number from 1 to 8. Inside each bag is 2 of every number, meaning there are 2 1s, 2 2s, 2 3s, and so on, up to 8. Each bag then gets 12 secret extra markers added to it, all with the same number on them. For example, we'll add 12 extra 7s to this one, but you won't know what the secret number is in your bag. With a partner, grab a bag, but don't look inside yet. That's important. Also, grab a piece of paper and a pen or a pencil. One partner takes the bag and the other takes the pen and paper. Your goal is to work together to try and figure out which number is on the secret extra markers in your bag. But there's a catch. You're not allowed to just tip them out of the bag and count them all. All you're allowed to do is to get the partner with the bag to take one marker out at a time, show it to the other partner, who will then write the number down on their piece of paper. They can also set up a table and make a tally if they like. The partner with the bag then has to put the marker back in the bag and give it a shake. Remember, no looking inside. You're allowed to repeat this as many times as you like. The partner with the bag takes out a counter, tells the other partner so they can write it down, and then puts the counter back in the bag and shakes it up. Just by doing this, do you think you can figure out what number is on the secret extra markers? You might be thinking no, since you can never see more than one counter at a time, and on top of that, the counter that you see is random. You might see any of the numbers from 1 to 8, and you might see the same counter twice, so you can't just count them. But despite all this, there is a higher probability of seeing the number on the extra markers because there are more of them. This means that after some time, you'll notice that you are seeing one of the numbers far more often than the others, at which point you can be pretty sure that that number must be the one on the secret extra markers. In this case, we can see that 7 is showing up far more often than other numbers. So that's the activity. One partner takes a counter out of the bag without looking inside, shows it to their partner who writes it down, then puts the counter back in the bag and shakes it up. Do this as many times as you need before you're sure that you know what number is on the secret extra markers in your bag. Then pour out all of the counters and see if you were right. So now let's think about the original question. How can quantum computers possibly be useful if they give us random outputs? The answer is if there's a high enough probability of seeing a useful output. Let's think about the activity we just did for a minute. Even though the number that you see when drawing an individual count from the bag is random, by checking a whole bunch of times, it eventually becomes clear that one of the random outputs was much more likely than the others. In the case of this bag, 7. This means that we can still extract some information by checking the outputs a whole bunch of times, even if each individual check was random. In this case, the information we extracted told us what number was on the secret extra markers. However, with a quantum computer, the idea is to program the computer so that there is a high probability of the outcome being the right answer to a question. For example, it might be something simple like 3 plus 4, in which case, as long as 7 is the most likely outcome, checking the output enough times would eventually tell us that the answer is 7. But this is too simple. In reality, the aim with quantum computing is to program the quantum computer to have a high probability of telling us the right answer to a really complicated question. For example, one day we might be able to use quantum computers to answer questions like, which drugs can be used to cure a particular disease? What's the absolute best way to invest your money on the stock market? Or how does the brain behave at a quantum level?